So can you see the screen?
Yes, ma'am.
1 second. So we have already proved this theorem in previous lecture. Now we will use this theorem to prove, to find or to compute some finite sums. Okay, so we will see one example based on this. Example. Compute summation k is equal to 1 to n minus 1 3 k times 3 raised to k. We want to compute finite sum k is equal to 1 to n minus 1 k 3 raised to k. So for this we have to choose ak and bk. So by theorem 2.8, in theorem 2.8 we choose ak and bk. So say ak is equal to k and bk. We will choose delta bk as 3 raised to k. Delta bk is equal to 3 raised to k. So if I choose delta bk is equal to 3 raised to k, so what is my, I require bk also, no? So what should be my bk?
3 raised to k divided by 2.
3 raised to
K by 2.
Yeah, 3 raised to k by 2. A raised to t upon a minus 1, right?
Plus
Summation a raised to t is nothing but a raised to t upon a minus 1. Therefore, bk is my 3 raised to k upon 2. Okay. Now we substitute. So from star we get, using star we get what we get? Summation k is equal to 1 to n minus 1. Now m I will substitute as n minus 1. K 3 raised to k is nothing but ak bk. Ak is my k, bk is my 3 raised to k by 2.
to k
And
upon
it runs from m to, m is my 1, m to
to n.
N. Here n minus 1, so n. Okay. Then minus what is that? Summation k is equal to 1 to what is that? N minus 1. N minus 1 delta ak. Delta ak means delta of k, right? And bk plus 1. What is bk plus 1? It is 3 raised to k plus 1 by 2. Is that okay?
Yes, ma'am.
Yes, ma'am.
So I will simplify this. What will be this now? N 3 raised to n by 2 minus 1 3 by 2. Is that okay? Upper limit and lower limit I have substituted. And minus now this summation k is equal to 1 to n minus 1. What is delta k? K plus 1 minus k. So just 1. So I won't write it here. 3 raised to k plus 1 divided by 2. Is that okay?
Yes, ma'am.
Now This will be n 3 raised to n minus 3 divided by 2 minus summation k is equal to 1 to n minus 1. Now I want to find this summation. So for that, that 3 by 2 is constant. I will take outside. And what will remain here? Let me erase.
3 raised to k.
Please mute. Minus 3 by 2 summation k is equal to 1 to n minus 1 3 raised to k. So what is summation k is equal to 1 to n minus 1 3 raised to k? What is this sum? Now I want to find this sum. What is that? How to find that? From equation 2.2. What is that?
Summation 3 raised to k 3 raised to k raised to n minus 1 plus c.
Raised to n minus 1.
Summation 3 raised to k summation 3 raised to k raised to summation 3 raised.
What is summation k is equal to 1 to n minus 1 3 raised to k
is equals to summation 3 raised to n plus c.
3 raised to k or yes, 3 raised to n plus c. Right? This follows from the formula 2.2, right? From equation using equation 2.2. We have already seen this, right? So what is summation 3 raised to n? This is finite sum, and we have written in terms of indefinite sum. Okay, so indefinite sum of 3 raised to n is 3 raised to n divided by 3 minus 1 means 2 and plus c, right? K is equal to 1 to n minus 1 3 raised to k. Now I want to find this c. So to find c, let n is equal to 2. Let n is equal to 2. So if n is equal to 2, this what let n is equal to 2, then equation 1 becomes, what it will become? K is equal to 1 to 1, 3 raised to 1. So 3 only, or I have to write K is equal to 1 to 1 or 2 minus 1 I will write 3 raised to k, which is equal to 3 square divided by 2 plus c. So if I simplify, this side is 3 only. This side is 3 only because summation k is running from 1 to 1. It is nothing but 3 only. So 3 is equal to 9 by 2 plus c. So this implies what is my c? What is my c?
Minus 3 by 2.
N by 2 means minus 3 by 2. Is that okay? So therefore summation k is equal to 1 to n minus 1 3 raised to k is nothing but 3 raised to n by 2 minus 3 by 2. Is that okay? That is my this sum. Now first I will give number to this, and for this I will give number, I will change the numbers 2 and 3. So using 3, equation 1 becomes, what it becomes? summation is equal to 1 to n minus 1 k 3 raised to k is this one. Okay, summation k is equal to 1 to n minus 1 k 3 raised to k is nothing but n 3 raised to n minus 3 by 2 minus 3 by 2, and value of this is 3 raised to n minus 3 by 2. Is that okay? 3 raised to n minus 3 by 2. Same thing I have written. Is that okay?
Yes, ma'am.
So if I simplify, I will get 2n minus 3, 3 raised to n plus 3 divided by 4. Is it right? Just take LCM. This is 4. So 2 times this, 2 times n, 3 raised to n minus 6 and plus 9. So minus 6 plus 9 will be plus 3. And if I take 2n minus 3 common, remaining will be 3 raised to n divided by 4 as it is. Is that okay? Is it okay?
Yes, ma'am.
Yeah, that is my finite sum. K is equal to 1 to n minus 1. K 3 raised to k is nothing but this one. So if you change n, you will substitute that value n here. You can find easily what is that k summation k 3 raised to k. Okay. So here we have completed how to find finite sums. Now the next section is section 2.3. Section 2.3. What is that? Generating functions and approximate summations. It is the last, I think. Yeah, generating functions and approximate summations. Of this chapter, this last section of this chapter. Yes. So first we will see what is generating function. Definition. Let yk of t be a sequence, possibly constant function of possibly sequence of we can write here sequence of possibly constant functions. If there is a function g of tx, so that g of tx is equal to summation k is equal to 0 to infinity yk t x raised to k. This is for all x in an open interval about 0. Then this small g is called generating function. the generating function for the sequence yk t. Okay, so what is generating function? Let ykt be a sequence of possibly constant functions. Need not be, but most of the time we will consider this as constant functions. Then a, we are defining a if there is a function g of tx, so that g of tx is equal to summation infinite sum ykt x raised to k for all x in an open interval about 0, then this small g is called as the generating function for the sequence ykt. Okay, so what is generating function for ykt? It is just summation infinite sum ykt x raised to k. And what is exponential? Another definition is exponential generating function. B, if there is a function h of tx, so that h of tx is equal to summation k is equal to 0 to infinity ykt x raised to k upon k factorial. This is also for all x in an open interval about 0. Then h is called as exponential generating function for the sequence ykt. Is that okay? This is exponential generating function. And so h of tx defined by infinite sum, but here ykt x raised to k upon k factorial, and here infinite sum, it is just ykt x raised to k. If it is just this summation, it is called as generating function, simple generating function. And if divided by k factorial is there, then that function is called as exponential generating function. Is that okay? These two definitions, generating function and exponential generating function. So if I am having a sequence ykt, then g of tx summation k is equal to 0 to infinity ykt x raised to k will be its simple generating function, and exponential generating function will be given by h of tx summation k is equal to 0 to infinity ykt x raised to k upon k factorial. Now, if generating function is known, then we can find if one of them means if generating function known or this exponential generating function is known, then we can find this ykt also. How we can find ykt? If we know generating function, note that for each t, ykt, what is ykt? Is the kth coefficient in the power series for g of tx with respect to x at x is equal to 0. Is that right? Ykt is the kth coefficient in the power series g of tx with respect to x at x is equal to 0. What is my g of tx? What is my g of tx? It is summation k is equal to 0 to infinity ykt x raised to k. So if I expand this, what is this? y0 t x raised to 0 plus y1 t x plus y2 t x square y3 t x cube and so on. Is it right? This is my g of tx. So what is ykt? y0 t is 0th coefficient, right? y1 t is first coefficient. Now if I want to find this coefficient, what should I do? If I differentiating with respect to x, what we get? Partially with respect to x, differentiate or partially, because it is function of two variables. Now I'm differentiating partially with respect to x. So what will be this? Dou g by dou x of g of tx. What should be it? X raised to 0 is 1. So y0 t will be constant. So it will be 0. Right? y0 at t is constant with respect to x. So this will be 0. First term differentiation will be 0.
0.
What is the differentiation of second term?
y1 of t.
y1 of t. What is third differentiation? 2 times
2 times
y2 t
y2
x
x.
x, right? Third term 3 times x square. So 3
Y
times y3 t x square and so on. Okay.
yes.
So what is if I want y1 t, now you can see this term is independent of x and remaining all terms contains x. So if I substitute the value of x is equal to 0, so dou by dou x of g at t0 will be just my y1 t. Is that right?
T.
Because
Yes.
remaining terms will vanish at x is equal to 0. All remaining terms will contain higher powers of x, right?
Yes, ma'am.
Alright. Now, if I want to find y2 t, what should I do now?
Again
So from
differentiate.
this
Again
I got
different.
y1 t. So again differentiating with respect to x. What I will get? Similarly, dou 2 by dou x square of g of tx is nothing but what? Y1 t is 0, right? Because it is
Yes, ma'am.
constant with respect to x. So what will remain? 2 times
2
y2
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 of t.
plus. Now here it will
plus
be
6 times 6
6
6
times
times y3 of
6
t
Y3
x.
t x and further again, okay, whatever may be the. So there will be 4 times x cube, no? So 12 times x square like that. Okay. Now, so if I want to find value of y2 t, shall I write here? 4 times, next term also I will write y4t x cube. Okay, and then dot dot dot. So here it will be 12 times y4t x square, right? And dot dot dot. So again, if now I want to find y to t. So what should be my y to t? So this implies dou 2 by dou x square of g at t0 is nothing but just 2 times y to t. Remaining terms you can see it contains x. So they will vanish. So this gives me y to t. Y to t is nothing but 1 by 2 dou 2 by dou x square g of t at 0. Is that right?
Yes, ma'am.
Is that right? Yeah. So I have found y1t. This one was my y1t. This is my y2t. Can you tell me what should be the y3t? How to find y3t? Similarly, y3t. If I want to find y3t, what I have to do? Again, differentiate partially with respect to x. So this term will get 0, and here what will remain? 6 y3t plus 24 y4 tx plus and so on. So if I substitute the dou 3 by dou x square g at t0, x is equal to 0 there, I will get 6 times y3t. Remaining all terms will become 0.
0.
Am I right? Similarly, we can find what should be my y3t then? 1 upon 6 dou q by dou x cube g at t
T comma
0. This I can write as 1 by 3 factorial. This 2 also I can write as in terms of 2 factorial. Next will be 24. So 24 will be 4 factorial.
4
Right?
factorial.
So I can generalize this formula then. G at t 0. So similarly we can find y3t and so on. And so on. So in general, how I can write ykt? 1 upon
k
k
factorial
factorial
K
dou
factorial.
dou
Dou
x raised to k
dou x raised to
g
k
of
g
t
at t
at
comma
0.
T
That will
x
be my
0.
IKT. So if I know generating function, then if I use this formula, I can find kth coefficient ykt. So each kth coefficient, if I find, I can find the original sequence for which it is the generating function. Is that right?
Yes, ma'am.
Similarly, we can show that if I know exponential generating function, like k is equal to 0 to infinity ykt x raised to k upon k factorial. If I know this one, how to find ykt? We can show that ykt is nothing but it will be that k factorial will get cancelled there. You can just expand it, take its partial derivative, okay, and check whether you get this h at t 0. Okay, so kth coefficient in the generating function power series we can find as by taking kth partial derivative of that series and substituting x is equal to 0. Is that okay? So you can check this.
Yes, ma'am.
Yes. Now we'll have example. Find, generating or compute generating function for the sequence ykt is equal to f of t raised to k. For the sequence ykt is equal to f of t raised to k for some function f of t. So I want to find generating function for this. So what is generating function by definition? By definition, what is g of tx?
Summation k equals to 0 to infinity
Infinity
yk t x raised to k.
k
X raised to k.
x raised to k, not x raised to t, x raised to k. So if
Yes.
I write, so what is my ykt?
F
It
of
is
t raised to k.
t
F of
raised
t
to
raised to k.
k x raised to k. So this can be written as summation k is equal to 0 to infinity f of t x raised to k. Right? Now this is the geometric series, which is geometric series. So what is its representation of geometric series? 1 upon 1 minus f of t x, provided that mod of f of t into x should be strictly less than 1. Is that okay? So this is my generating function for ykt, where ykt is nothing but f of t raised to k. Is that okay? Just you have to write the power series in the form of power series and then its sum. We know this, it is a geometric series and its sum is given by summation k is equal to 0 to infinity x raised to k is 1 upon 1 minus x. It converges to this sum, right, when mod x is less than 1. So here instead of x, f of t into x is there. So 1 upon 1 minus f of t into x, provided that mod of f of t x is strictly less than 1. Is that okay? Is that okay?
Yes, ma'am.
Yes. So now this result can be used to find other generating function. Okay. This result is used to, can be used to find other generating function. For example, if we differentiate, what is dou by dou x of this 1 upon 1 minus f of t x? We know that 1 upon, or first let me erase this. We know that one upon 1 minus f of into x is nothing but what? It is summation k is equal to 0 to infinity f of t into x raised to k, right? We know this relation. Now if I differentiate partially with respect to x, differentiating partially with respect to x, what we get? Dou by dou x of 1 upon 1 minus f of t x, which is equal to dou by dou x of summation k is equal to 0 to infinity f of t x raised to k. So can you tell me what is dou by dou x of 1 upon 1 minus f of t x?
Log of 1 minus f of t.
How it will be log? You have to use division rule. 1 minus f of t x bracket square, then
F of t of
1 minus f of t x into differentiation of 1, but differentiation of 1 is 0, minus 1 into differentiation of this with respect to x. So what is differentiation of this with respect to x? It is minus f of t.
F of t.
Is it right? I am using division rule here, which is equal to. So
Minus
what is
f of t.
huh? What is now dou by dou x of this series? Dou by dou x of this. What is first term? F at 0, x, sorry, f at, not f at 0, f of t into x raised to 0 means 1. First term is 1 plus f of t x plus what is second term? And so on. What is dou by dou x? First term is 0, second term is
F of t.
third term is 2 times f of
F
t
of
into
t
x
x.
plus 3 times f of t into
F of t
x square
x square.
and so on. So what is this?
So on.
So if I want to write this in summation form, how I should write?
Summation 1 to infinity.
1 to infinity if I write, then here I want to write 2, 3 and so on. So 1 times x raised to 0, x raised to 1. I can write. So what should it be? K times f of t x raised to k minus 1, k running from 0 to or 1 to
0 to
1 to na?
Ma'am, 0 to no.
For k, if I want to write this,
1 to
k f of t x raised to k, 2 f of t x raised to 1, k should be 2. So 0 to the 1 to.
0
1
to
to 1 to 1 to
And that 0 also I can write as 0 times f of t x raised to minus 1 and so on I can write.
yes,
So
ma'am.
0 also if I write, no problem. Actually this,
Yes,
for this summation starts from 1. But if I want to write from 0 to also no problem, because first term will give 0 because of k is 0. Is that okay? So if I write from 0 to infinity also, no problem. Is that okay?
yes, ma'am.
Yes. So what is left hand side? F of t divided by 1
1
minus
minus f of t
brackets square.
whole square.
Yes. So k x raised to k minus 1. Now so can I write that k f of t raised to k x raised to k? Can I write this? Zero to infinity
Yes.
k f of t raised to k. Raised raised to k is also there, no? Here it is 1. It's a 1 page, no? Or f of t raised to 1, and this is also square. No, here it is cube. Here it is f of t square. So इथे mistake झाली ना? Nobody pointed out. What is this? Here f of t x raised to 0. Here what is this? F of t bracket square into x square. So f of t bracket square will be as it is into 2 times x derivative. Here it will be f of t bracket cube times
Cube.
x square. Next term will be 4 times f of t raised to 4
4 x
x
cube.
raised to cube and so on. So here what it should be? Here k now 0
Yes,
F
x.
of
ma'am.
t
K
raised to k.
So here it should be 1
f of t raised to k.
k k k f of t raised to k, and if I write it as x raised to, if I want to write it as x raised to k, what should I do? Multiply on both sides. Can I write like this? I want here
Yes,
x raised
ma'am.
to k, so I am multiplying on both
Yes, ma'am.
sides by
By
x.
x.
Since it is independent, this summation is independent of x, I can directly take it inside. Is that okay? So now you can see here. Upon k for which sequence it will be then. Okay, I will write this. K is equal to 0 to infinity k f of t. K f of t I can write as f of t x raised to k. Okay, so f of t raised to k x, so f of t into x raised to k I am writing, or if I don't write also no problem. Not necessary. Okay, k times f of t raised to k x raised to k, so that is my ykt. Ykt x raised to k. So this will be the generating function LHS. LHS will be the generating function for the sequence ykt. Is that right? X times f of t divided by 1 minus f of t x is the generating function for the sequence ykt is equal to which sequence? K f of t raised to k. K f of t raised to k. Is that okay? K f of t raised to k. That is my another function. So if I want to find generating function for k f of t raised to k, its solution, its answer will be x f of t upon 1 minus f of t x. Is that okay? So using generating function of this sequence, we have found the generating function for the new sequence k f of t raised to k. Is that okay?
Yes, ma'am.
Now what is the exponential generating function? Similarly, show that we can show that the exponential generating function for the sequence f of t raised to k is given by summation k is equal to 0 to infinity f of t raised to k x raised to k upon k factorial. Can you show now this? I want to find exponential generating function for the sequence f of t raised to k. Just now we have found simple generating function for f of t raised to k. Now if I want to find exponential generating function, what I have to do? H of tx will be summation k is equal to 0 to infinity ykt x raised to k upon k factorial. Right?
Yes, ma'am.
By definition. Just use that one and show that it is e raised to f of t x is nothing but f of t raised to k x raised to k upon k factorial. So exponential generating function is e raised to f of t x. What is this series? E raised to f of t x. What is this series? Summation 0 to infinity f of t raised to k x raised to k upon k factorial. Is that okay? Now I will give some examples, exercise examples. Homework. Find or I will just give page number 40. Exercise section, exercise 2.39 A D. Also example 2.41 and 2.52. Okay, this is today's homework. You have to find generating functions for the given sequence. Okay. So today we have seen generating function and exponential generating function, and by definition you can find it for some examples. Is that okay? So this much is enough for today. Tomorrow we will start Bernoulli polynomials. New topic, Bernoulli polynomials.